Hello everyone and welcome to this video on creating a bullet time effect in Unity. Here's what we'll be making today. Throughout this video, I'll explain about how time works in Unity and how you can manipulate it while still getting really smooth results. I also just want to mention that I'm on a fixed video schedule, so you can expect a new video both Wednesdays and Sundays. So let's just go ahead and get started. So here's the project we're going to be working with today. It's fairly simple, but I will of course have a download link for you in the description if you want to have it on your own system. If we go ahead and hit play, we can see what it currently looks like. So we can move around and we are able to shoot these explosions that will create a force that acts on these rigid body objects, which are currently just red cubes. However, we currently have no slowing down. So let's go ahead and create a bullet time effect. So to get started, let's create an empty game object. So right click in the hierarchy, go create empty, and let's reset the transform on that to make sure it's centered in our scene. We can now rename this to something like time controller or time manager, and we can go ahead and drag it to the top of our hierarchy and add a new component. And this is where we want to add our actual script. So let's just go ahead and call it the same thing, the time manager. Let's hit create and add, and let's double click this to open it up in Visual Studio. So let's clean this up a little bit. Let's delete our two functions, and let's also delete the two using tags up here because we're not going to be using anything under system.collections. Now we can create two variables that will allow us to configure how our slow motion will occur. The first one is going to be a public float, and this one is going to be the slowdown factor. The slowdown factor is going to control how much we will slow down time when we do our bullet time effect. The lower the number, the more slow we're going to be moving. So I'm going to default this to something really low, say 0.05. We also need a variable to define for how long the slowdown will occur. So in that case, we'll create another public float called the slowdown length. And we can go ahead and default this to something like 2, meaning that we will be slowed down for 2 seconds total. Now we need to create a method that will change some time settings around in Unity in order to make the game engine slow down. We'll go ahead and write void, and the name of the function is going to be something like bullet time or slow down or slow motion. I'm just going to go ahead and call it do slow motion. And inside this function, we can set time.timescale. So what is timescale? Timescale is basically a value that determines the scale at which time is passing. If timescale is 1, time will be passing at a normal pace. We say that it's running in real time. If timescale is 0.5, time will be passing 2 times slower than real time. And so we can adjust timescale to a value between 0 and 1. The lower the value, the slower the game will run. So let's go ahead and set our time.timescale equal to our slowdown factor. Because our slowdown factor is equal to 0.05, we can very easily calculate just how many times slower we are going to be moving at. And we do that by saying 1 divided by 0.05, which is equal to 20. That means that we will be moving 20 times slower than normal. This function should actually now slow down time, but we also need to call the function from somewhere. So let's go ahead and find the place in our project where we can do that. On my player, I created a script called explosion gun, and this is responsible for shooting out an explosion wherever the user is pointing. So let's go ahead and double click on that to open it up in Visual Studio, and we can have a look at what's in here. So I have a few references, one to the explosion prefab that we want to spawn, and one to the camera. In the update loop, I basically just check if the user presses the fire button, and if he does, we shoot. Then I do a bit of raycast trickery to shoot out a ray from our camera's current position and then just straight forward. And if we hit something, I go ahead and create an explosion at the impact point. And this is basically where we also have the opportunity to slow down time. But in order to do that, we need a reference to our time manager. So let's go to the top here and create yet another public variable. And this is going to be a public time manager. And we'll just go ahead and call it time manager with a non-capital T. So right after we instantiate the explosion, we can now say time manager dot do slow motion. But the problem here is that our slow motion method is currently private, so we cannot access it from within this script. To change that, we simply go into our time manager and insert a public in front of the void. So now this method is public, and so we can access it from within this class. So we call it do slow motion and hit save. So if we now head into Unity, we need to select our player and drag in the time manager into the time manager variable. There we go. We can now hit play, and we should see this working, but something weird is going to happen. So if I hit shoot here, we can see that time is slowed down quite drastically, but it almost seems that the game is lacking. However, our mouse movement and the particles here are smooth. So what is causing this? Well, the reason why is that whenever we adjust our time.timescale, we also need to adjust time.fixed delta time. Fixed delta time is one of those things in Unity that just sounds really scary, but actually it's quite simple. We know that the update function runs each time the computer draws a frame. This normally happens many times each second and allows us to make changes to an object over time. But how many times the update function runs each second depends on how much load the computer is under and how fast the components in the computer can perform. This is normally not an issue, but when it comes to doing physics calculations, everything becomes much easier and more reliable when we know beforehand how many times a second the function will be called. Therefore, Unity uses a separate function called fixed update to calculate its physics. Fixed update is of course called a fixed amount of times per second. So the bug that we just saw in Unity occurred because fixed update got slowed down so much that we could visibly see it updating. Luckily, we can change the time between each fixed update through script. That is done by modifying the fixed delta time variable. We normally want our fixed update to run around 50 times per second, which means that fixed delta time should be 1 over 50, which is equal to 0.02. And then we multiply with the time.timescale so that when we slow down time, making timescale smaller, we will also decrease the time between each fixed update. So to make sure that we adjust the fixed delta time inside of our time manager, we simply go time.fixedDeltaTime equals time.timescale multiplied with some small numbers, say 0.02, which is the standard. Make sure you do this after we adjust the time.timescale. So now when we save this and head back into Unity, we should get a very smooth slow motion effect. So if we go over here and hit shoot, we can see just how nice that looks in comparison. So much better. However, we are currently just staying slowed down. Time doesn't go back to its normal state. So in order to slowly return back to our normal timescale, we need to use the update method. So let's go here and write void update. And update is of course called each time the computer draws a frame. And unless your game is ridiculously hard to run, that means many times a second. So what we'll do is each frame add a tiny number to time.timescale in order to slowly return it back to 1. So to do that, we write time.timescale plus equals, and in here we write 1 divided by the slowdown length. So right now our slowdown length is 2, which means that this will say 1 divided by 2, which means a half. And so each second will add 1/2 back to the timescale. And so in 2 seconds, it should return to normal. However, that's not what we are currently doing. What we're currently doing is actually adding a half onto the timescale each frame, which might be drawn, say, 60 times a second or 120 times a second. So what we need to do is multiply this whole thing with time.deltaTime. So to do that, we wrap this in a few parentheses here, and then we say multiply with time.deltaTime. And time.deltaTime is the amount of time passed since we drew the last frame. And that means if we are drawing a lot of frames a second, this value is going to be small. And if we're only drawing a few frames a second, this value is going to be big. And that means that it is going to even out this value so that over 2 seconds, we are going to be adding 1 to the timescale. And we'll do that in very small increments. If that's kind of hard to wrap your head around, I totally get it. No one really understands time.deltaTime the first time, but really the more you get to use it, the more you understand. However, this is currently going to propose a problem, and that is that time.deltaTime is actually also affected when we change the time scale. And so this whole equation becomes really weird. So what we do instead is use time.unscaledDeltaTime. And this is the exact same thing as delta time, the amount of time elapsed since we last drew a frame. But unscaled delta time is not affected when we change the time scale. So right now we are altering the time scale in order to have it return to 1. But time scale can actually be greater than 1. If we want to speed up our game, we can set time.timescale equal to something larger. Say, if we wanted to run 2 times faster, we'll set it to 2. And so right now, unless we are slowed down, this is just going to keep increasing. And so our game will run faster and faster. If we hit save on this right now and then hit play, we should see that our game just slowly speeds up. And indeed it does. We're able to run quicker and quicker until, of course, we shoot something and then we are reset back to 0.05. So we'll go in here and say time.timescale equals math time.clamp, and the value we'll want to clamp is time.timescale, and we want to clamp it between 0 and 1. And this means that we'll either be totally slowed down or running at a normal speed. And so we won't be able to increase the timescale between or further than to the value 1. And so when we hit save now, we should see, if we hit play here, that time will not increase above the 1. And if we go ahead and shoot something, time will slow down and then slowly go back up to 1. And so now we have that old school bullet time effect. What I really suggest you do is combine this with some changes in audio. A very normal thing to do is adjust the pitch of your game so that when you're slowed down, you will decrease the pitch and then increase it as you slowly increase the timescale. But that's really just a lot of things that you can do to play around with this, and I suggest you just have a lot of fun. Finally, I just want to say, if you're making a shooter and want to grab some weapons, you can go to devassets.com and select the modern weapons pack here. There are some really nice high quality weapons here for you to download. It's pay what you want, so you can totally decide the price. And yeah, we really hope that you are going to enjoy them. That's pretty much it for this video. If you're making a shooter, I really suggest you check out my latest tutorial on creating a sniper scope effect in Unity. I think it turned out pretty well. If you want to see more, subscribe to the channel. You can expect a new video every Wednesday and Sunday. Thanks for watching, and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in December, and a special thanks to Sultan Al-Sharif, Derek Hemskirk, Faisal Marify, James Calhoun, Robert Bonham, and Jason Latito. If you want to become a patron yourself, you can do so at patreon.com/Brackeys.